Hello everyone. So today we will study the polarization concept. Okay, so let's start the lecture. So before coming, just I will give you a simple definition. So today we will study about the wave polarization. Okay. So in the wave polarization, the polarization first of all, let's see what is polarization, how it is identified. Polarization is identified by studying the trace of electric field of z is equal to 0 plane. Okay, that is the propagation field for various advancing time. So polarization basically क्या होता है ना, हमारा trace of the electric field है. Okay, and where we keep z is equal to 0 plane. So just write this definition. Polarization is always identified by studying the trace of the electric field. Okay, of z is equal to 0 plane, means in the xy plane. Okay, that is z plane. What is z plane? That is the propagation direction. Okay, and for various advancing time, means time will continue. Okay, so we will take some example, then you will start. Very important concept, few times question came in get from here. So first we will see linear polarization. Okay, so in linear polarization there will be two cases. Okay, the first case is single E field component. Okay, single E field component means there will be single means E field will have the electric field will have the single component in one direction. Okay, so that can be given as EZT x, that is equal to E naught sine omega t minus beta z ax. Whenever equation of electric field is given like this is the linear polarization. See here, electric field have only one component and that is in the ax direction. Okay, so the graph will be like this for this kind of polarization. Either electric field will be in the, let's suppose this is our x-axis, y-axis and z-axis. Okay, I will just draw one important thing because I will draw dotted just because it is going down to the plane. Okay, so in this our electric field is only in the x direction, like this. Sometimes it can be in the only y direction. Okay, or sometimes it can be only z direction. So such kind of polarization is called as the linear polarization, जहाँ पे electric field की एक ही component हो. Okay, so now there is one more case of linear polarization. Let's suppose this is our case A. Okay, So coming to the case B. Case B is two components in phase. So how this wave can be represented using the equation? So this can be represented like this. Okay, there is a two component of electric field that is in the x direction and y direction. So this is given as E1 sine omega t minus beta z ax plus E2 sine omega t minus beta z a y. Okay, so see here, what is the case here? Here you have electric field in the ax direction and ay direction. So there is the component of the electric field is in the two direction, two component, but both are in the same phase. Just see this here, omega t minus beta z. So this is the exact phase. If you take it as theta, it will be also as a theta. So this kind of wave equation is given. Then this is also the linear polarization. So this equation is also a type of linear polarization. Okay, now coming to the next case, that is circular polarization. Okay, in circular polarization what happens, there are two electric field component जिसका magnitude equal होता है, means amplitude is equal, and the phase difference between them is 90 degree. Okay, so if one component is in the x direction, so other in the y direction. In the previous case it can be represented as like this. This is our x, y. So our electric field is represented as E1 sin omega t minus beta z ax. So this is our E1, and this is also in this direction. Sorry, omega t minus beta z will be in some other direction. So let's suppose this is our E1. See, E2 is also in the omega t minus beta z. So this is E2, both in the same direction. Sorry for the wrong diagram. Oh, okay, just take it like this. So both in the same direction. Okay, so this is the case of our linear polarization. So coming to the next, that is circular polarization. Here what happened, two electric field component that is equal in amplitude and out of phase by 90 degree in time. Two electric field component or equal in time. Today my voice is little different because of cold and fever going on in the North India. So okay, equal in time and out of phase by 90 degree in time. Oh sorry, here I have written time. This will be equal in amplitude. Amplitude same होता है and phase difference is of 90 degree, out of phase by 90 degree in time. So such kind can be given as, the equation of such kind of wave is given as EZT xy. This time electric field is in the x and y both direction. That is given as E naught sine omega t minus beta z. Okay, ax plus the another, see both will have equal amplitude, so amplitude will be E naught only, and but the out of phase by 90 degrees. So here sine if shifted to 90 degree will become cos. Okay, so if the equation is given like this, then this is the case of circular polarization. So the graph will become like this. And how to identify such thing? Let's suppose this is our equation. Okay, now we will take our case 1 at t is equal to 0. अगर t का वैल्यू अगर 0 हो तो हमारा ex क्या हो जाएगा? That is equal to at 0. Let's suppose beta z is also 0. Okay, let's suppose if t is 0, then our what will be our beta z? Beta is equal to 2 pi by lambda. Oh no, sorry, oh, it's okay. When t is equal to 0, our ex, that will be is equal to e naught, and ex will be 0 because sine 0 is 0, because this is our case. This is the case of t0. Okay, t is equal to 0, and our ey is equal to sine 0 is cos 0 is 1, so that will be e naught. So it will start from the e naught. Now when we take t is equal to t by 8. Okay, so in that case, when t is equal to t by 8, our ex, that is equal to ey, that is equal to e naught by root 2, and omega t is equal to pi by 4. Here omega t will be 0 only. Okay, so pi by 4 is a positive, so it will go in anti-clockwise direction. So the same way this wave is polarized, you can substitute other values also. T is equal to t by 4, this will be this point, because omega t is equal to pi by 2. Okay, and ex is equal to e naught, ey is equal to 0. So in like this way you can construct the diagram also. Okay, are you getting confused? Okay, let me take example in the fresh view. I have drawn the curve earlier only. Okay, let me take, because this is very important, because sometimes they will ask you, and they can ask you the right polarization or left polarization. See, the direction also important. If in exam, अगर exam में ये question आता है, आप directly दोगे circular polarization, तो जरूरी नहीं कि आपका आंसर सही हो. ऑप्शन ए है. What is this polarization? Okay, find polarization of this equation. Okay, so option A is right circular, option B is left circular. Okay, so now we will take each thing very carefully. Case 1, when t is equal to 0, our omega t is equal to 2 pi by t into t, that is equal to t0, that is 0, and then e naught is equal to, sorry, ex is equal to this component will be 0 because sine 0 0, and ey is equal to e naught. So our graph will start at ey, the direction of e in the y direction, that is e naught. This point is t is equal to 0. Now case 2, we should definitely take two cases. T is equal to T by 8. Omega T is equal to uh, this T and T get cancelled, that is equal to 5 pi by 4, and our Ex is equal to Ey is equal to E naught by root 2. So this will be T is equal to T by 8. Now the third case, T is equal to T by 4. Okay, so omega T, that is equal to 2 pi by T into T by 4, that is equal to pi by 2, and our Ex is equal to E naught and Ey is equal to 0. सी अगर Ey is equal to 0 अगर हुआ तो इसका मतलब क्या होगा, y एक्सिस के अलॉन्ग कंपोनेंट 0 होगा, तो मतलब ये x एक्सिस पे लाई करेगा. So this is the point t is equal to t by 4, that is E naught. So our curve is going like this. You can take further more points also to verify. So and now what is the direction of wave? That is the z direction. So what we will do, z direction, what we will do, we will curl our hand. This is this wave is going, this graph circle is going in the anti-clockwise direction. So our right hand finger curling direction will be anti-clockwise and the thumb will be in the positive z direction. Now what we will see, see what is the sense of rotation. I need to just a definition. Sense of rotation for left and right with thumbs along the propagation and the fingers folding advancing the time. The hand that satisfied defines the left and right. See इसमें क्या है कि हमारा थंब को प्रोपगेशन डायरेक्शन में रखना है, वेव के प्रोपगेशन डायरेक्शन में, जो कि जेड यहाँ पे पॉजिटिव जेड एक्सिस है. ओके, सो thumb will be the positive z direction, and the curling of our means will close our hand in this way, so that curl will enclose the wave. So wave is in the anti-clock direction. So which hand satisfy this? See, if you will do right hand, then your when the thumb is up, the finger is curled in the anti-clockwise, but here in the question, in the wave, this is a clockwise direction. See, this direction is clockwise direction. तो देखो, अगर थंब अप है तो क्लॉकवाइज डायरेक्शन में कब फिंगर कर्ल हो रहा है हमारा, लेफ्ट हैंड से ही. सो लेफ्ट हैंड सेटिस्फाई दिस. सो दिस इज लेफ्ट सर्कुलर. सो आई विल जस्ट गिव अ डेफिनेशन हाउ टू फाइंड दिस. Sense of rotation for left and right with the thumb along propagation and thumb को हमेशा वेव के प्रोपेगेशन डायरेक्शन में रखना है, and the fingers folding along advancing time. टाइम हमारा कैसे एडवांस कर रहा था, clock in this question that was in the clockwise direction. Sometime it may be in the anti-clockwise direction depending on the equation. Okay, the hand that satisfied defines the left and right. अगर राइट हैंड सेटिस्फाई करेगा तो राइट सर्कुलर होता है, अगर लेफ्ट हैंड सेटिस्फाई करेगा तो लेफ्ट सर्कुलर होता है. द हैंड दैट सेटिस्फाइड defines left and right. Okay, now the next case, that is the elliptical polarization. In elliptical polarization, there will be two cases. Okay, one is the third one, that is elliptical polarization. Okay, in this 2e field component unequal in amplitude and out of phase by 90 degree. अगर इक्वल एम्पलीट्यूड होगा तो सर्किल हो जाएगा. ओके, सो 2e field component unequal in amplitude and out of phase by 90 degree in time. So this polarization, the example is given as EZT XY. See, unequal in amplitude. So one का एक का amplitude E1 होगा sin omega t minus beta z in the x direction, and other का amplitude unequal होगा, that is E2 होगा. So E1 is not equal to E2 cos ओमेगा टी माइनस बीटा जेड, एंड कॉस यहाँ पे इसलिए लिए हैं क्योंकि 90 डिग्री फेज शिफ्ट इन टाइम है. अगर देखो E1 इज इक्वल टू E2 होता है तो ये हमारा सर्कुलर पोलराइजेशन हो जाएगा. ओके, अंडरस्टूड. दैट इज आवर लास्ट केस. बट हेयर अनइक्वल इन एम्पलीट्यूड है, सो E1 इज नॉट इक्वल टू, अगर E2 हुआ, in that case it will be elliptical polarization. Done. I'm just erasing it because now we are studying elliptical polarization, so don't get confused. And see, अगर आप लोगों को कोई भी डाउट हो तो आप डायरेक्ट हमारे से पूछो. व्हाट्सएप नंबर मैं अभी आपको शेयर कर देता हूँ 7004148826. वीडियो पॉज करके नंबर फिर से लिख लो. डाउट हो तो पूछो. EMT is very tough and you should not keep any doubt in your mind. Okay. And one more case in the elliptical is like two E field component in different phase, that is EZT XY can be given as E1 sin omega t minus beta z ax plus E2 sin, here sin ही है but there is some phase shift, that is by theta degree. Okay, in the y direction ay. So this is also the case of elliptical, and the graph will come like this. And the सेंस ऑफ रोटेशन लाइक लेफ्ट है और राइट इलिप्टिकल है, ये सेम रूल से फाइंड करेंगे. हमारा फिंगर कर्ल होना चाहिए अकॉर्डिंग टू द एडवांस इन टाइम डायरेक्शन में, और थंब अगर वेव प्रोपगेशन डायरेक्शन में. जो हैंड सेटिस्फाई करेगा वही हमारा सेंस ऑफ रोटेशन कहलाएगा. सो अप टू दिस क्लियर. So you just solve the previous year examples based on these kind of questions, then you will definitely get this theory very easily. See, actually examples you only need to solve from the previous year book, and if you have any doubt you can ask me. I will be available every time for all of you. So sorry. Coming to our next topic, this topic is over, wave polarization is over. Now the next topic is reflection या transmission of EM waves. Reflection a transmission of EM waves. So let's suppose this is a surface, okay, separating two medium. So let's suppose this side is our medium 1, this side is our medium 2, okay, and our eta 1 and epsilon 1 is the characteristics of medium, and eta 2 epsilon 2 is the characteristic of medium 2. So this is in, let's suppose, in the rho z direction. So when the wave is incident, that can be denoted as rho I, okay, and this wave can be electric field or magnetic field EI or HI, incident wave. That's why it is given as an incident wave. Sorry, this is our z axis. Now the some part of the wave incident will be reflected back, that is given as ER or HR, that is reflected wave, that is noted as rho R, and the some part will be transmitted, that is ET or slash HT, that is given as rho T. So see what happened, rho I is the incident, rho T is the transmitted wave, and rho R is the reflected wave. So our first case is the normal incidence, like when wave is incident normally. When it is incident normally, then just remember this formula. If ER by EI, that is refracted electric field divided by incident electric field, that is given as tau, that is given as reflection coefficient for E field. This is a formula, and this formula is very important because it will be used in the transmission line. The next formula is transmitted electric field divided by incident electric field, that is given as a small tau. This is called as transmission coefficient. देखो रिफ्लेक्शन कोफिशिएंट क्या है, रिफ्लेक्टेड इलेक्ट्रिक फील्ड डिवाइडेड बाय इंसिडेंट इलेक्ट्रिक फील्ड. ट्रांसमिशन कोफिशिएंट क्या है, ट्रांसमिटेड इलेक्ट्रिक फील्ड डिवाइडेड बाय इंसिडेंट इलेक्ट्रिक फील्ड. ओके, दिस इज फॉर द ई फील्ड. फॉर मैग्नेटिक फील्ड क्या होगा, तो एच आर बाय एच आई और ट्रांसमिशन कोफिशिएंट एच टी बाय एच आई. सो जस्ट राइट वन नोट पॉइंट. The first note point, that is the magnitude of tau is always greater than 1, or no, sorry, this tau is less than 1. Sorry again, see, this small tau is always greater than 1, or this tau is less than 1. It depends on the, या तो टाउ ग्रेटर देन 1 होगा मैग्नीट्यूड, और रिफ्लेक्शन कोएफिशिएंट का मैग्नीट्यूड लेस देन 1 होगा. ये किस पे डिपेंड करता है, on N1 and N2, that is the impedance of the medium. eta 1 and eta 2. Okay. The second note point, that is reflection coefficient, is always less than 1. Oh, sorry guys, just one mistake. Here it is tau only, that is transmission coefficient. Reflection coefficient is always less than 1. Transmission coefficient क्या हो सकता है, greater than 1 or less than 1, depending on the eta 1 and eta 2 of the medium. And the third note point, that is incident wave, that is equal to, see incident है तो कुछ पार्ट हमारा रिफ्लेक्टेड हो रहा है, कुछ पार्ट हमारा ट्रांसमिटेड हो रहा है, तो दोनों का सम हो जाएगा, that is rho r plus rho t. Okay. Now there is some field relation, that is relationship between field. Those relations are given as like this: EI, that is for the incident wave, that is equal to N1 into HI, because see EI and HI both are incident and both will be in the medium 1, that's why we are using N1. ET, that is transmitted electric field, that is equal to eta 2 into HT. Okay, and you also know eta is equal to E by H, that's why all the side E is equal to eta H. But what are the relation of incident and transmitted wave? We are giving that. And for the refracted wave, ER, that is equal to minus eta 1 into HR. When reflection in direction occurs, one of field direction changes. When reflection in direction occurs, one of field direction changes. Now we can apply our boundary condition, and before that let's have a note point. We already studied this, that is Ex, Hy and propagation direction. So in the, if the wave is in the Ax, means electric field in the Ax direction, magnetic field in the Ay direction, when we will curl our fingers from Ax to Ay, our thumb is showing in the Z direction, so propagation is Az. When our electric field in the Ax, magnetic field in the minus Ay, then propagation is in the minus Z. This is incident. When minus Ax, it is in the minus Ax direction, it is in the Ay direction, then it will be minus Az, that is reflected. This is just for reference I have given. You must be knowing this because we have already studied to find the direction from the E and H field direction. Now we will apply boundary conditions. Let me check my laptop how much charge it is. Yeah, it is charged. So after applying boundary condition, see the tangential component will be same. Okay, so that will be given as ET1 is equal to ET2 and HT1 is equal to HT2, and power incidence is normal to boundary, then both transverse field are parallel to boundary. Okay, let's suppose this is our boundary. Okay. So when the normal power is there, then just write this point. Power incidence is normal to boundary, then both transverse field are parallel to boundary. Okay. E tangential, that is given as E incident plus E refracted, that is equal to ET, that is equal to E tangential 2. So we can write it as, when we will divide by EI, here we will get 1 plus ER by EI, that is equal to ET by and EI. What is our ER by EI? See, ER by EI, that is equal to reflection coefficient, ET by EI, that is transmission coefficient. So we will get our relation 1 plus reflection coefficient, that is equal to transmission coefficient. Very, very important equation. You can take it as equation number 1. The next is H tangential 1, that is equal to Hi plus Hr, that is equal to Ht, that is equal to H tangential 2, because the tangential components are equal. So here Hi we can write as Ei by N1 minus Hr we can write Er by N1 and Ht we can write Et by N2. From where did we wrote this? From this formula. From these three formula we have written Er by Hi is equal to Ei by N1 and Hr is equal to minus Er by N1, okay, and Ht is equal to Et by N2. So we wrote this formula from the previous formula. So now what we will get, we will divide it by Ei, and we will take N1 that side. So it will be 1 minus Er divided by Ei, that is equal to N1 by N2 into Et divided by Ei. Now our Er by Ei, that is reflection coefficient 1 minus big tau, N1 by N2, that is, keep it like this, and Et by Ei, that is transmission coefficient tau. This is our equation number 2. Now our equation 1 is given as 1 plus big tau is equal to a small tau. When you solve these two equations, you will get, solving equation 1 and 2, we get reflection coefficient tau, that is equal to intrinsic impedance of medium 2 minus intrinsic impedance of medium 1 divided by intrinsic impedance of medium 2 plus intrinsic impedance of medium 1. That's why our reflection coefficient is always less than 1, because n2 and n1 both are positive and denominator both are added. So that is equal to Er divided by Ei. This is also the formula of reflection coefficient. that is equal to ER divided by EI. See, actually when the power gets cut, it's okay. Let's try. So the 4 note point I will give you right now. The first one, that is tau h, that is equal to HR by HI. Okay, that is given as minus N1 ER divided by N1 EI. So this will become minus tau E, that is equal to N1 minus N2 divided by N1 plus N2. These all are formula derived from the previous formula. So you can sit with the notebook and try to derive all this. Tau P, that is equal to rho R by rho I, that is the reflected power divided by incident power. PR and PI are the like that. So that can be given as tau, reflection coefficient of electric field, into reflection coefficient of magnetic field, that is equal to minus reflection coefficient of electric field square, that is also equal to minus reflection coefficient of magnetic field square. Okay, because TH is equal to minus TE. This formula you should remember. This is the second note point. Third note point is transmission coefficient is 1 plus reflection coefficient for power of E and H. The fourth note point, if N2 is greater than N1, tau E is always greater than 0, that is E reflects in phase. The reflection coefficient is greater than 0 means it is reflected in phase. Okay, if you will substitute N2 and N1, you will get tau E is greater than 0 in the formula of tau, that is equal to N2 minus N1 divided by N2 plus N1. If N2 is less than N1, then there is no need, then obviously tau E is less than 0. In that case, if tau E is greater than 0, tau E, that is equal to 1 plus tau E, is always greater than 1. So that is equal to ET by EI is greater than 1, is implied that transmitted electric field is greater than incident electric field. So for today we will study up to here only. So tomorrow just revise this lecture, solve previous year gate question based on the wave, propagation of wave, polarization of wave, and we will meet again. And thank you so much for watching this lecture. If you have any doubt, you can ask me on WhatsApp or on the phone call. Thank you very much again.